Hello, statistics scholars. Welcome back. This is our third lecture for Chapter 1. In this lecture, we will continue our focus on defining basic terminology and explaining some of the foundational concepts of statistics, specifically classifying data, qualitative versus quantitative data, levels of measurement, and defining variables. So let's begin with data. Data are the building blocks of all statistical studies. By definition, data are just raw facts and figures that pertain to a measurement of interest. Data, the plural, are values assigned to a specific observation or measurement. A data set is a collection of measurements, scores, or observations. A datum, singular, is a single measurement or observation, commonly called a score or raw score. Data are classified into two general categories: quantitative data, which can also be continuous or discrete data, and qualitative data. Quantitative data take on numerical values. Quantitative data provide us information about quantities, how much or how many of something. If scores indicate the amount of something that is present, measured, or counted, then those scores are classified as quantitative data. What might be some examples of quantitative data? I'll give you a minute to think about that. Great. So some examples of quantitative data are age, number of people in the household, height, weight, salary, temperature, amount of income, etc. These data are represented by numbers. Because the data have numerical meaning, we can summarize them in many ways. The key features of quantitative variables are center and spread. What that means is that we can calculate a measure of center and a measure of spread, which we'll talk about in Chapter 2. Quantitative data can be further classified as either continuous or discrete data. Continuous data are measured. Quantitative data are continuous if they can assume an infinite number of real values or an infinite range of values. Continuous data can take on a range of measurements. The key is, if you measure to get the value of the data, it's continuous. Examples of continuous data are distance, temperature, height, volume, length, speed, amount of time it takes to take an assignment, etc. Discrete data are counted. Quantitative data are discrete if they can only take on one value. An example of a discrete variable would be the score given by a judge to a gymnast or ice skater in a competition. The range, 0 to 10, and the score is always given to one decimal, like a score of 8.5. The key is, if you count to get the value of the data, it's discrete. Examples of discrete data: goals scores, or goals scored. Players can't score 1.5 goals. Number of fatalities. We can't have 59.5 fatalities, or 59.5, or 59.75 fatalities. The number of pets in the household, number of foreign language spoken, runs scored in a baseball game, etc. There was actually a famous survey done decades ago that stated American families have 2.5 children. Is this realistic? This is a good example of someone reporting data without fully understanding the type of data they're reporting on. Number of children is a discrete value, and what should have been reported is American families have 2 to 3 children. See the distinction? So here's another way of looking at the difference between discrete and continuous data. Notice here, discrete data are counted. There are 3 cones, or cone 1 has 2 scoops, and continuous data are measured. Cone 3 weighs 79.4 grams, or cone 2, ice cream is at 8.3 degrees Fahrenheit. Now let's take a look at the second category of data, qualitative data. Some variables cannot be measured in amounts, but a score classifies an individual on the basis of some category. These data are called qualitative data. Qualitative data are also known as categorical data. Each score belongs to one of a set of categories. So what might be some examples of qualitative data? I'll give you a minute to think about this question. Great. So here's some examples. Gender, Social Security number, student ID number, race, type of housing, birthplace, college major, etc. Qualitative data place individuals into categories. Qualitative data are descriptive information that can be observed or counted, but not measured. The key feature of qualitative data is the percentage in each of the categories. Here are some more examples of qualitative data. I'm a bird, I'm yellow, I'm awesome. As you can see, each of these examples describe the object or individual in terms of its qualities. One more quick example on data, putting it all together. Data are classified into 2 categories, qualitative and quantitative. Qualitative data provide descriptive information, and quantitative data provide numerical information. Quantitative data are further classified into 2 categories, discrete and continuous. Discrete data are counted, and continuous data are measured. Who would have thought of so many ways to look at data? Here's another way to classify data. We classify data by the way it is measured. This distinction is critical because it affects which statistical procedures we can use in our analysis of the data. Numbers mean different things in different contexts. The meaning of the number 1 on a license plate is different from the meaning of the number 1 in a race, which is different still from the meaning of the number 1 in a hockey score. The kind of information that scores convey depends on the level of measurement that is used, or the scale of measurement that is used in measuring the variable. There are 4 levels of measurement scales: nominal, ordinal, interval, and ratio. Nominal data are qualitative only. Each score does not actually indicate an amount. It is used for identification. This means that nominal variables can be classified only in terms of whether the individuals belong to some distinctively different categories. The key here is that nominal scales or nominal data classify or categorize individuals. This data type does not allow us to perform any mathematical operations like adding or multiplying. We also cannot rank order the data in any way from highest to lowest. Think nominal equals names or labels or qualities. They identify different categories. No concept of more or less. All we're doing is differentiating between categories. For example, all we can say is that two individuals are different in terms of category A. So for example, they are of a different political party, but we cannot say which one has more of the quality represented by that category. So typical examples of nominal variables are gender, type of dog, eye color, hair color, city, type of residence, ice cream flavors, fruits, phone numbers, zip codes, etc., etc. So hopefully you can think of your own examples for nominal data. Ordinal data have all the properties of nominal data with the added feature that we can rank order the scores from highest to lowest. Ordered sets of observations. Think ordinal equals ranked or ordered. Ordinal data identify different categories, but the categories have a logical order. However, we still cannot perform mathematical operations on these data. A typical example of ordinal data are the socioeconomic status of families. For example, we know that upper middle is higher than middle, but we cannot say that it is, for example, 18% higher. Ordinal data are qualitative data where individuals are placed in a specific order or in some natural way. Another example, behavior is ordinal if we categorize it as 1 for excellent, 2 for very good, 3 for good, 4 for bad, and 5 for very bad. We know that the category excellent is better than the category very good, and that the category very good is better than the category good. There's some natural ordering here, but it is limited because we do not know by how much excellent behavior is better than very good behavior. In its strictest sense, ordinal data are qualitative. However, there are statisticians who argue that ordinal data are also quantitative. An example of quantitative data could be movie ratings with 1, 2, 3, or 4 stars. However, we still cannot claim that a 4-star movie is 4 times as good as a 1-star movie. Other examples of ordinal data: letter grades, A, B, C, D, and F, restaurant ratings, school rank, freshman, sophomore, junior, senior. Hopefully you can come up with some examples for ordinal data of your own. Interval data are strictly used for quantitative data. It allows us to not only categorize and rank order the items that are measured, but also to quantify and compare the sizes of differences between them. Now we get to work with the mathematical operations of addition and subtraction when comparing values. We can also calculate average values. Interval data identify different categories, logical order, and the distance between categories is equal. Think interval data has constant equal intervals. The distances between data points are meaningful. With interval data, each score indicates an actual quantity and an equal amount separates any of the adjacent scores. Even though interval data do include the number 0, it's not a true 0. It does not mean none of that variable is present. The key here is that you can have less than 0. So interval data allow for negative numbers. For example, temperature, as measured in degrees Fahrenheit or Celsius, involves interval data. because 0 degrees does not mean that 0 heat is present. You can have even less heat at -1 degrees. In research, interval data are common with intelligence or personality scores. A score of 0 does not mean 0 intelligence or 0 personality. Other examples of interval data: pain sensitivity, happiness, depression scores, and anxiety scores, stress, well-being, amount of money in the checkbook, etc. Hopefully you can come up with your own examples for interval data. Ratio data also involves strictly quantitative data. With ratio data, the scores reflect the true amount that is present. Here, the scores measure the actual amount. There is an equal unit of measurement, and 0 truly means that none of the variable is present. The key here is that you cannot have negative numbers because you cannot have less than nothing. In addition to all the properties of interval data, ratio data feature an identifiable absolute 0 point. The term true 0 point means that a 0 data value indicates the absence of the object being measured. For example, 0 salary indicates the absence of any salary. With a true 0 point, the rules of multiplication and division can be used to compare data. This allows us to say that a person who is 6 feet tall is twice as tall as a 3-foot person, or that a 20-year-old is half the age of a 40-year-old. There is a fine line between interval and ratio data. The same statistical procedures are used for interval and ratio data, which is why for this class we will use scale to identify either interval or ratio data, so you will not need to worry about the difference between interval and ratio data. The next 2 slides graphically summarize levels of measurement. So remember that for this class, the levels of measurement are nominal, ordinal, and scale. We are combining interval ratio data. In every statistical study, questions are asked and characteristics are observed or measured. These characteristics that are observed or measured in a study are called variables. A variable is any characteristic, condition, or quality that is recorded for subjects in a study. Variables are things that we measure, control, or manipulate in research. The word variable highlights the fact that data vary. In other words, a variable is anything that, when measured, can produce 2 or more different values. Variables can be reported or classified using levels. For example, handedness can be considered as a variable with 3 levels: left, right, or ambidextrous. Gender can be considered as a variable with 2 levels, male and female. Socioeconomic status can be considered as a variable with 3 levels, upper, middle, and lower class. Variables can also be reported or classified as scores. For example, temperature, height, speed, distance, anxiety, depression, happiness, well-being can all be considered as variables with many possible scores.